I hope everyone had a good lunch and that you're ready to learn a lot about C#. So is everyone in here a C# developer? If you're not, raise your hand. Do we have any Java, PHP, Ruby, Haskell? All right, so everyone knows C#. So I want to talk about what's changed in C# as a language. I'm going to talk about how it's progressed over the years. So we'll just talk briefly about C# 2, 3, 4, 5, and a little bit about 6, and then we'll talk about the future of C# and what Microsoft is currently working on. So hopefully there's going to be a lot of new things here, and you'll have a lot of new things that you can introduce in your programs come Monday. But before we dig into that, my name is Filip Ekberg. If you have any questions after this talk or during the talk, ping me on Twitter. I'll try to help you as much as I can. I'm a Microsoft MVP, and last year I was here as well, and I said that, well, being an MVP means that I go around to conferences, talk about things that I know how to Google about. Doesn't really mean that I know how to build software. And honestly, nothing has changed since last year, so I'm still doing the same thing. I wrote a book called C# Smorgasbord, and I did this last year as well, so everyone here gets a free copy of the digital version. Ping me on Twitter if you want one. The only requirement is to press the green thing when you go out here after the session. All right, so C#. C# is pretty much the best language out there. Since we're all C# developers, hopefully we can agree to that. But honestly, it takes everything from declarative, functional, and imperative programming languages that most of the developers love in those languages. We have influences from SQL, from C++, from C, from Scala, from Ruby, from F#, and from all of these different types of languages. And we'll see that when C# changed over these years, they added a lot of cool things from all these different types of languages. I don't know if you knew this, but generics, for instance, came from a project on the F# language. So they started doing research about F# and building F#, and they introduced generics, and then they pulled that into C#. So that's a pretty great addition. I originally did Java development, and I still believe there's no generics in Java. So looking at Java as well as C# and comparing these two, how they kind of progress over the years, C# is just rapidly adding features to the language to make it easier for us as developers to build software. So if we just look back through history and talk about C# 2, which was the first iteration of the language after we got if statements and while loops and functions and all that, you know, the basic things you want to use in a programming language. We got things like generics, which changed the way that we build software. We got partial types, which allowed us to do WinForms and WPF and all of these other crazy things that you can do with partial types. We got anonymous methods and iterators and nullable types. So we no longer had to say we could use nullable integers, and all these value types could now be used as nullable, like reference types. We got getters and setters with separate accessibility, static classes, and a lot more. So in C# 2, they introduced things that made it easier for us to just build software that's a little bit more readable. When the next version was released, they introduced a lot of things, one of them being the implicitly typed local variables, which is a mouthful to say. Easier is to say they introduced the var keyword. And I remember having this discussion so many times with coworkers at the time. I don't work with them anymore. They thought that using the var keyword was a way for you to write dynamic code in C#. Does anyone recognize that? Well, it's not, because dynamic was added in the next version of C#. So using the var keyword is just a way for us to we don't have to be so explicit anymore. So that's pretty nice. We got object and collection initializers. We got the auto properties. So coming from a Java background, that was really nice to, I don't have to be so verbose anymore. I don't have to specify the field and then do a function for a getter and then for a setter and so forth. So it's a lot easier. And then we got a heap of more features like anonymous types, extension methods, query expressions, lambda expressions, expression trees, and much more. You know, if you group those together, they introduced one big thing in C# 3, which allowed us to do link. Link allowed us to do things like link to SQL, work a lot more easier with collections of data. So if C# 2.0 introduced things that makes it easier for us to just write readable code, C# 3 introduced helpers for us to write code that work more easily with larger collections of data. Now, if we look at C# 4, we don't have so many features added here. They did add the dynamic language runtime, and with that, they added the dynamic bindings, which means that we could do things like Iron Python and Iron Ruby and introduce all these different dynamic programming languages into C#. I'm not saying that's a good idea, but they did add that to the language to make it possible for us to more easily write extensions and write scripting inside our applications. Now, C#5 only introduced 2 things. And you might see a pattern here that they add smaller and smaller and smaller features with each iteration of the language. Now, I'm not saying that asynchronous methods is a small thing. It's kept me employed for the past few years because it's a hard thing to master, and a lot of people tend to do deadlocks. I have a course on Pluralsight on how to do asynchronous programming properly. Let's check that out. But they did add that in C#5. But we see here that they didn't add too many features in C#4 and 5. And the fact is that most of us know how hard it is to add things to a project that's lived for a few years. Now, I don't know how long C#'s been around. Let's say 10 years. Imagine going back 10 years and add things to a code base and introduce something like asynchronous methods in the compiler that's probably written in C++. Now, that's not a trivial project to do. So at that time, Microsoft decided to introduce a project called Roslyn. Who's not heard of Roslyn? So Roslyn, also known as the .NET Compilation Platform, it's a project that Microsoft introduced to make it easier to add language features. But how do you do that? Well, you throw away the old compiler and write a new one in C# and VB. So they started reworking the compiler to be able to add more language features. But that meant that they had to look at the old compiler and make sure that the new compiler generates the same code. And that means that all the bugs from the old compiler needs to be introduced in the new one as well. Which is an interesting thing, right? So we don't want to introduce bugs that we've had in the past, but they had to do that with the compiler. And what's even more interesting is that they wrote the compiler in C# and VB, which means that they used the old compiler to compile the new compiler. And I do believe that they used a new compiler to compile the even newer compiler. So it's a mouthful, but they did introduce that. And what's even more cool with this is that it's open source. So Microsoft is not only pushing the code to GitHub, but they do a lot of commits. They do a lot of releases. So they have 82 releases of Roslyn, which is the C# and VB compilers. There's not 82 releases of Visual Studio. This is independent from the IDE. And they have a lot of issues. So that means that we, as developers, can go ahead and say, well, I want to add this language feature to the programming language. Maybe I want to introduce tuples. Maybe I want to introduce pattern matching. Well, if you want that, you just go in here and you create an issue to Microsoft. And they keep track of everything. They add the design notes from their language design meetings, and they talk about all these things in the open. And then, of course, you can submit your pull requests. So I actually submitted a pull request to the Roslyn project. I changed a spelling mistake in the documentation, but I still contributed to the compiler. Put that on my CV. All joking aside, what they do is add the design notes from these meetings. So here we can see from 2016, they started talking about language features for C#7. They started talking about tuples and pattern matching, and they even added all the information about why do we want this. They do proper documentation, right? So this is what every developer dreams of. Why do we want to build this? How do we do it? How does it impact current developers? How can it change the behavior of how we build software in the future? And this is one of the things they actually did add to the language. But introducing Roslyn and making it easier to add language features means that they might want to focus on the language that most developers use. Does anyone do VB in here? One? So sorry, but there's no more language parity, which means that if they add a language feature to C#, they might not add it at the same time to VB unless it's really easy. But the same goes on the other way around. So they might add something to VB that's not coming to C#, like XML literals, for instance. Now, this here means that we have a lot of potential with this new compiler. So now Microsoft can just shoot out new features. How many of you are using Visual Studio 2017? Almost all of you. That's great. So that means that most of you have probably used the C#6 features. They've been around since Visual Studio 2015. That's when they first released the Roslyn compiler as a part of Visual Studio. I'll just go through this quickly and then we'll look at some code. They introduced something called using statements for static members, auto property initializers, which is a way for us to introduce proper read-only auto properties. Awaits inside catch and finally blocks, null conditional operators, which is also known as the Elvis operator, string interpolation, dictionary initializers, expression-bodied members, exception filters, and name of operators. So let's have a look at some code. So I have a few of them here. I have a few projects inside Visual Studio. I'll just minimize that here. So we'll see here that I've created these different console applications. They're just here to illustrate these different language features. So the first one is using statement for static members. So we'll see here that what we can do here is that on the top, we're saying using static system.console. That means that everything inside system.console that's static is now part of where I can look for methods. So instead of me having to write console.writeLine, I can now say just writeLine, because it's going to look that up automatically. So that's pretty neat. And if I introduce a method in here that's called writeLine as well with the same signature, it would of course take the one that's closest to it. So it's doing the same resolution as it's doing when it's looking for methods in other cases as well. It takes the one with the best match. And then we see some other things in here, which is also new. We have something called string interpolation. String interpolation means that we add this $sign here in the start, which is the same way that we do when we add the @ symbol. When we have the @ symbol in front of a string, it means that it's not going to escape backslashes, for instance. But with the string interpolation, it means that whenever we find curly braces, like we have here to the left, it's going to evaluate the expression inside that. It's really just going to convert this into a string.format. So what happens is that instead of us having to write string format and then have a placement and then have the parameter after, this is just a nicer way to do that. And then we also have the name of operator. And the reason that you say name of program and not have the hard-coded string program is because you would have a really hard time changing the name of program when you do refactoring. So you'd find the reference to that, which makes it easier when you do logging and so forth. All right, so the next one they added is auto property initializers. This is a proper way for us to introduce read-only auto properties. So I can say here that I have this property called name, and the initial value is going to be Filip. And if I try to change this, it's just not going to work. I'm going to get a compilation error saying, well, you can't really do that. Right? Now, and of course, I can print that out to the console as well. And you could change this in a static constructor or in a normal constructor. It's just static here because it's the program.cs. So that's just going to make it easier for us to initialize values for our auto properties. And of course, we can have a private set here as well if you want that. So this works with all the different variations of auto properties. Now, if you're doing a lot of asynchronous programming, you'll probably be happy about the addition of awaits inside the catch and finally blocks. This is a way for us to use the asynchronous principles inside catch and finally. So let's say that we do some asynchronous operation. We go ahead and talk to the web here at the first line here. We grab some data. Something didn't really work out as it should. We might want to clean up to add something to the database. And afterwards, we might want to just dispatch a message onto a queue and do that asynchronously as well. So previously, this wasn't possible. But now they've added this feature in C#6. Now, one of my favorite features is the null conditional operator, also known as the Elvis operator. So if we look at one of these methods down here, it's called process people. It takes a list of people. Now what I'm doing is that I'm iterating over all these people. And I'm saying, well, I want to get the person unless the person is null. If it's null, I want to evaluate that entire expression as being a null expression. So I'm saying, well, give me the person if it's not null. And if it's not null, give me the name of that person. And the same goes for this one here. So I'm saying, well, give me the person unless it's null. Give me the address unless the address is null, and then give me the street name. So this here allows us to write code that's less prone for null reference exceptions. And of course, you can be crazy, and you can do the same thing, for instance, for arrays or collections. So here I'm just declaring null as an array, so it's not initialized. I'm saying, well, give me the array unless the array is null. Give me the first index unless it's null, and then give me the name if that's available. If one of these here is null, it's going to evaluate the entire expression as being null, which is why we can do this here at the end. So we can say, well, if any of these are null, just use this default value. And if I run that, of course, it's going to say, Filip lives as no idea, unknown lives at no idea because, if we look at the top here, we can see that it says, well, create a new person. The person doesn't have an address. Then we have a person that's not initialized. And it handles that properly. And then we got something called expression-bodied members. Now, expression-bodied members is for people like me who are lazy, that don't like to write method bodies. So what I do here is that instead of declaring this entire method body to say return name, I can simply use an expression and say, well, fat arrow and then name here, and it's going to know how to return that properly. So you see here, most of the things they add to C#6, or at this point, it's things that makes it easier for us to just write code, write less code that handles more things in the background, to get rid of all this boilerplate code that we have to write. It's really the same with C#5 when they introduce asynchronous principles. We've been able to use the TPL to do asynchronous programming for a long time, but it's been kind of tedious to do that. And you've had to write a lot of boilerplate code to make it properly. Now, finally, in C#6, they added exception filters. Now, imagine that I'm doing this web call here. I'm saying, go ahead and grab the data from google.com, and then I catch an exception down here and say, well, catch this exception, which is the web exception, when the status is a timeout. Then we might want to do a retry. And in the second case, I'm saying, well, if there's a name resolution failure, which means that the DNS is probably down, we can do something else. We can indicate that the application is in flight mode, or the computer doesn't have Wi-Fi or something like that. So this is neat. You no longer have to catch the entire web exception and then do an if it's this, if it's that, if it's something else. Because what happens if it's not caught here, it's being thrown back to the caller. So for all the other web exceptions that doesn't match these two here, it's going to be thrown back to the caller. So just handling that out of the box. All right. So C#7. Which is the current version of C#, or well, actually released a new version just a few days ago. I don't know if you've noticed. But C# 7.1 is out as well, and I'll cover the changes in that as well. So C#7 was released with Visual Studio 2017, and they introduced a few interesting concepts, one of them being tuples and deconstruction. So tuples is simply put a way for us to return multiple values from one method. Which you could say that, well, you can just create a type for that, but sometimes it's just nicer to use tuples. They also introduced pattern matching, which is a really nice feature. It allows us to match an object to another object and then do a switch case on the type of object that is. I'll show you an example of that. And then they added something just to make people happy that work with large numbers. So digit separators and binary literals. It's just a way for us to split up our larger numbers and hexadecimal numbers and binary numbers a little bit nicer in our apps. And they also added local functions. I haven't really found a good use case for that yet, but sometimes you want to just add a function that's in your current scope. But I'd argue that you probably should refactor your code if you need a local function. Then they added ref returns, which means that I can say, well, I want to return a reference to this object. So you have been able before to pass in a reference to an object, but now we can return a reference to an object as well. And they've done some improvements to the out keyword as well. So let's have a look at that. So in C#7, we got tuples. So up here at the top, we have a function called getPoint, which has two values being returned from it. Now, what's interesting here is that I can say, well, I also want to return a string, and I can just append more parameters that I'm returning from this here. But let's not do that, because this is called getPoint. So this here makes it a little bit easier for us to just simply return two values from this here without introducing a struct or a new class. And when we use this here, we can use different types of methods of deconstruction. Deconstruction means how do we grab these two values? How do we get the x and y into local properties or local parameters? The first one is to say, well, call getPoint. GetPoint is going to be, the result of that is going to be in this local variable here. And this local variable is going to have two properties, or two fields. So what happens here is that I can say, well, point.x or point.y. I can zoom in a little bit. And this here allows us to use those two values. Let me get rid of this. And then the other type of deconstruction we can do is to say, well, I want you to map the result of getPoint, which is two parameters. I want you to map that into the local variable x1 and y1. So now I don't have to write anything else but x1, because that's now an integer, which it has mapped those two values to. The last one is to say, well, I don't really want to specify the type. So I'm going to say getPoint returns two variables. These two variables are going to be mapped into x2 and y2. And of course, that's going to be two integers. So if you run this here, it should say the same for all of these different types. So x is 100 on all the different places, and y is 200 on all of them. So that's super simple. It allows us to easily return multiple values from a method, and we can have different types of deconstruction based on how we want to use that. Right, so next up is pattern matching. Now, pattern matching has been available in other programming languages for a long time, but it was recently added in C#. So what it means is that in this case here, I have a shape. It could be a rectangle, it could be a triangle, it could be a circle, it could be an ellipse, it could be whatever type of shape you want to use. And then I'm saying, well, I want to do a switch on this shape, and if it's a triangle, I want you to map that to this local variable called t, which means that I can use all the properties that are available on my triangle. So a triangle has multiple sides, so we have side A, B, and C. But in case the shape is a rectangle, I don't have A, B, C, right? So we have rectangle has a x and y and width and height. So it just automatically converts this into that, or casts it to that object. So this means here, if I run this, it's going to say, well, since this is a rectangle, we have x, y, height, and width. But if I go up to the top here and say, well, the type is now a triangle, run it again, it's going to map that to the correct type. So this here is going to remove a lot of, type.getType is equal to type of my rectangle. If it's a rectangle, do a conversion to that particular type. This is a lot nicer, so it'll just reduce our boilerplate code. Next up is local functions. So I've introduced a local function down here at the bottom. It's simply a method I call calculate, which then introduces a local function called fib, which calculates Fibonacci, and returns the Fibonacci of x, which is passed into this function. All right? And that's only available in the scope of this method down here at the bottom. And then we see here at the top, we have the digit separators and binary literals. We have a binary number here representing the value of 16, which you can now do. And then we can have these separators. If you want a really large number, we can just add these separators. But that's going to take a long time to calculate the Fibonacci for. So let's just run this here. And we'll see here that it doesn't print it out with the underscore. It's still an integer. And this calculate method here used that local function. Now, for ref returns, which is the fourth language feature that I want to talk about, I'm actually using a local function as well. So I'm saying here, this function returns a reference to an integer. I'm going to pass an array of integers, and I'm going to give it a position of the integers that I want, the integer that I want the reference for, and then it's simply returning a reference to that particular value. Now, this is where it gets a bit crazy. So first, I'm printing out the value on the first position, or index 1, which is 2, and then I'm getting the reference to that element, and then I'm reassigning it to the value 10, and then I'm printing it out again. So this one here at the left, where it says element at is equal to 10, is the equivalent of doing source 1 is equal to 10. Right? So if I run this here, it's going to give me the two different values, because I've now changed that, because I got a reference to that particular type, so I can change the value. Now, these changes here is probably more common if you work with really high performance applications, where it's a lot more cost effective to pass a reference rather than doing a copy, and so forth. So the last one is out improvements. I actually found myself doing this just a few days ago when working in a project where we were interacting with legacy code that requires us to specify out parameters. Now, previously, what you've had to do is to say, well, I want an int called x, and then you say, well, out x, right? But now what you can do instead is that you say, get rid of that, and then in place say, when there's an out variable, I want you to declare the x if it's set, right? So if I run this here, of course, it's going to say 100 and 200, because it introduces those two new local variables. So we, of course, have X available here, X and Y. So these are the changes that they've recently done in C# 7. They've added more features in C# 7.1, but we can kind of see a pattern here that they try to allow us to reduce the amount of code that we write. So they introduce tuples, so we don't have to create a new class. They introduce pattern matching, so we can get rid of all these if-else statements when checking types. So if we talk a little bit about what's coming next, the fact is that they're doing a lot of work on the language. By no means are they adding less features in the upcoming versions. And honestly, it feels like they're just adding, like they're doing 7.1 now, and then they might do 7.2, and then 7.3, and then who knows what they're doing after that. But they're also talking about major features being added in C# 8. So if one's interested in what's coming in the upcoming versions, they do have a track of what's happening and what's being added to these languages, or to C#. So on GitHub, they have this language features status where they talk about how are we progressing with this proposal. So internally at Microsoft, they have a champion for each language feature that they want to add. And they're in charge of talking about that in the language design meetings. And they talk about how do we introduce this and what kind of side effects does this feature have. For instance, they removed record types from C# 7, which they really wanted to add, but it was just too much of a hassle to get the IDE support in place in time. So hopefully they'll get that into C# 8. But when they talk about new features, like it's not only about adding that to the compiler. They need to add support in Visual Studio. They need to have documentation. It's just a big process. So C# 7.1 introduced something that I find pretty cool. It's async main. So I don't know if you write console apps, but most of my demos are console apps. So I'm really happy about the fact that I can now do asynchronous main methods in console applications. They made the default expression a little bit more simple. And they introduced something called infer tuple names, pattern matching with generics, and ref assemblies. Ref assemblies is a way for us to work with metadata out of assemblies. So I mentioned that C# 7.0 came out with Visual Studio 2017, and they actually recently released C# 7.1. And of course, I have demos for that as well. And the way that you say that you want to use these features is that you go into the properties of your project. This is a per project setting. You go down to the bottom and you choose Advanced in the Build tab. Click Advanced here, and then we can say which language version do we want to use. So we can say, well, we want to use the ISO 1, 2, C# 3, and so forth. And I'm going to say I want to use the latest minor version, which means that it's now going to use C# 7.1. And it's going to use the latest version of the compiler as long as it's installed. So, which means that as soon as C# 7.2 is out, it's going to use that as well. This means that I can now go ahead and go into my project. And I can say that I have an asynchronous main method which returns a task. So I no longer have to do task.run.wait in my console app, because that's a bad pattern. We want to avoid doing that in our applications. And then we can see here that I'm using this new default expression. So the default of the default expression before was that we wrote something like this. But, you know, it's too many characters. So why not make it a little bit more simple? It's almost like someone has too much time coming up with these features. I don't know. It's not like it bothered me before. I don't know. All right. So the next one is that they've changed the way that tuples work, or they've improved the way that tuples works. So if we change back to C# 7.0, which is now deprecated. No, I'm just joking. It's already old. No, it's not. So what I'm doing here is that I'm creating a new object called point. Point has an X and Y property. And then I'm saying, well, I want to create a new tuple. And the way that you can do that now is by simply having two parameters, parentheses like this here, and just specifying the ones that you want in there. Previously in 7.0, which is now old for you guys because we know all about that, is that you had to do this. You had to explicitly say that, well, this one is going to be called X and this one is going to be called Y. But now what they do is that they infer that instead, which means that I can say, well, tuple.x, and that's now available on my tuple. What's interesting as well here is that previously in C# 7, you had to 7.1, getting confused. You can write item 1, right? So you can write tuple.item1. That's like the basics of the tuple. You can still do that, but it's not available in the IntelliSense here because they remove that because they want you to use the better version of it instead. So you could still do tuple.item1 and .item2. So there are a few less features added to this minor version of C#, but it kind of makes sense that you don't add breaking changes or adding large sets of features to a minor version. Unless we talk about C# 7.2, which is the next version of C#. They're adding a few extra features that will make it easier for us to work with references. Again, if you work with high-performance applications or doing game programming, which I don't know if you do that in C#, but if you do and use monogame, you're probably going to be very happy about this here. So they're going to allow us to do ref read only, which means that I can have a reference that you cannot change, which is a little bit odd, because I'm not sure how they're going to implement this here, but it'll certainly be a nice feature to have. So the second line here says vector add, and then you can specify this is only an in parameter. So it's not something that can change. So they add this keyword called in here, and this allows you to pass the reference, but no one inside this method can change it. Now, this is not set in stone, so this might change. One could say it's not read-only. So they're also going to add non-trailing named arguments, which means that if we have a lot of overloads for a method, we can specify we want to choose this one by specifying the first name of that parameter. And then we don't have to do it for the rest of them. They were going to add something called private protected. So you can now say that your classes or functions are private protected, which is totally confusing. But it's good for people that write APIs or NuGet packages. So in the CLR, which is the common language runtime, we've always been able to do protected and internal, which is probably a better name, I think, because it indicates that, well, it's protected inside my assembly. So I can inherit from this type, or I can override this inside my type, but no one outside my assembly can do that, which is pretty much what private protected means. Unless I'm totally confused by that naming, so don't blame me. They're going to add conditional ref operators. So we can say that, well, if this condition is evaluated to true or false, give me this reference or give me this reference. Previously, you had to do this on 2 or 3 lines of code with a few if statements, but doing it inline like that is pretty nice. It's all about cutting the characters. Because as I think Scott Hanselman said, you need to value each keystroke on your keyboard, because you only have so many keystrokes in your life. And then they're going to improve the digit separators. Again, I don't know who comes up with this, but someone likes hexadecimal numbers. So that's all for C# 7.x that we know now. So now we can talk about even more features that might be added or might not be added. We can talk about C# 8. So there's a language candidate or a 8.0 candidate with 19 open issues on the C# lang repo on GitHub. So they want to add everything to C# 8. Just like they wanted with C# 7, they wanted a heap of features added to the language, but with only so much time, some of these might be scratched from the language. So C# 8 is going to hopefully now introduce record types. It's going to introduce default interface methods, and I'll show you a few examples of these in just a moment. They're going to introduce nullable reference types, null coalescing assignments, recursive patterns and pattern matching improvements, negated condition if statements, null conditional await, and hopefully a lot more. So a pattern that you might see here is that they want you to stop writing null reference exceptions. They want to improve the ways that we work with nullable types. It's almost like someone on the design team regretted adding null in the first place. All right. So record types. If we have this triangle here, which is a base type of shape, we want to make sure that, well, when you create this triangle, you have to specify A, B, and C. And the way that we do this with record types is by simply saying, well, this triangle here requires A, B, and C. So instead of having to write all these outer properties, we can just simply add that to when we declare the class. Like, I think this is pretty cool, but that's my subjective opinion. Everyone might not like it. And there's a lot of edge cases which make this a bit interesting. It's probably why they didn't add it to the language yet. Next one, is default interface methods. That sounds dangerous. So imagine being able to just add methods that are implemented to your interfaces. That's great. Is it? I don't know. So this way here, the way that the reason they want to add this to the language is because imagine I implement an interface that I got off NuGet, and I update this NuGet package, and the author of the NuGet package introduced a new method on the interface. But I don't care about that method yet. So I have to go in and say, well, I'm going to implement this method, throw new not implemented exception. They could just do that in here instead. So this is a way for them to say, well, this is a breaking change. It's going to be added in the next version. So you have time to upgrade your solution. So in this case here, I can simply say, well, point here implements the iPoint interface, which means that I could say, well, I have an iPoint is equal to a new point, and then I can call getPoint without actually having this implemented in my class. What the proposal talks about as well is that, well, if we simply remove the iPoint here and we know that it's a point, this won't work because it doesn't know that you're talking to the interface. So they have a lot to figure out to make this understandable. But if you think about this even further, I talked to a coworker and he said, well, this is a way for us to introduce multiple inheritance in C#, which can be dangerous. All right. So nullable reference types. Imagine us being able to say, well, this object can never be null. We can add this question mark here to say, well, this point can never be null. And if we do that with parameters, if we pass a something null into that method, no one would be able to call it. And hopefully the compiler notices and tells you at compile time. So if we do this here, it should blow up. Now, remember, these are all features that they want to add. They're not implemented, which is why I can't show them in Visual Studio. And I didn't have time to implement them myself. So, next up is null coalescing assignment. So we've always been able to do something like this here. We can say, well, I want to set x to a value. I want to set it to y if x is null. Now, they want to make this even easier to write less characters. So what we can do here is to say, well, only assign x to y if it's really null. I don't think they've agreed on the notation yet, but I think it's great. It's going to be so confusing. It's going to end up looking like one of those really hard, understandable languages, like Lisp. I don't know. They want to add negated conditions in if statements, which means that we no longer have to write this here. So this here is also a mouthful. Well, if shape is triangle not, do this. How about we say, well, if triangle is not a triangle, or if shape is not a triangle, or if it's not shape is triangle. Again, they haven't really decided on this one, but the last one is my favorite, unless shape is a triangle. I don't know. I vote for the last one, because adding more keywords in the language is great. Keeps me employed. All right, so null conditional weights. Sometimes we say, well, I want to await the task unless the task is null because maybe you've changed the task from somewhere else. How about we say, only run the task if it's not null? And we do that by introducing another notation by saying, I don't know if it's screaming at the task or what it's doing, but yeah. That's going to be great. So to wrap this up, they are doing a lot of changes in C#, and hopefully some of the features in C# 6, 7, 7.1, and 7.2 and 8 are new to you, and I think that some of these features are going to make our applications hopefully faster to build, easier to maintain, and for those of us that go into project and fix things that other people break, it's going to keep us employed. Because adding things like async and await and making it easier for us to write code that's just generating a lot of code in the background is great, because it means that we need to understand what's really happening. We need to understand the problem that they're trying to solve, right? Pattern matching is great, but we really need to understand how it affects our applications. So with that, I want to thank you all for coming here to listening to me. Ping me on Twitter if you have any questions. If you want my book, press the green button on your way out. And thank you so much for having me.